using a responsive and user-friendly application. So, this is the reason for our tools. Well, we focus more on the applications. So we want developer have a easier experience when building application in our blockchain. So this is we know that currently the application the app is often clunky because for example you need to wait for several blocks when interacting with the blockchain. It's also not very user friendly because for example you need a wallet and you need to know how to manage your key. So what we trying to do is to address this issue so that it's easy for both the user and the developer. The first thing I want to talk about is the smart account. So with smart account, we can enable functionality that have developer can easier manage their application. So here is a definition of smart account. That is a type of account that can be controlled by a smart contract that allow programmable function such as transaction validation and recovery. So we know that, for example, without smart account, what we can do to have transaction validation, you can build a smart contract, and then as a user, you will need to handle your transaction, then send it to the smart contract, which will do the validation part before sending it to other modules. However, doing so is very complicated for both the user and the developer. For example, as a user, it will be very hard to track the activity on the blockchain because you have to bundle all the messages and send it at the contract execution. And for the developer, well, it's not fun either because you have to take care of a normal account and also smart account as well. So what we want to do is a smart account that eliminate all those issues. What we do is we build a new module that manage the smart account contract. What this means is that to be considered a smart account, the contract has to be whitelisted by that module, and the module also has the abilities to pause, to blacklist, and remove the account as well. Then a smart account should be controlled by a keypad, just as any normal account. With that, we can have the smart account as the sender of the transaction. So it's not like when you proxy transaction to a smart contract. When you're doing so, the contract is the sender, but the initiator is another account, the normal account. With smart account, the two contract is the same. And with that, it makes it easier for other modules to interact with that account. And the last point is that the transaction will be validated both before and after execution. And this is where we put the smart functionalities into smart account. Here is a diagram showing how our smart account works when sending a transaction. The first thing is finding the corresponding public for a smart account. With that, it will validate the signature of the transaction. Then it will call the validate function to the version B module. It will call to the corresponding smart contract and check the result. After that, it will execute the message, and then we call the smart contract again to check for with the after execute message. And with the pre and after execute message check, we can do most logic. For example, like we can do spend limit. You know, like to limit that one account cannot transfer too many coins in a transaction. So with that, at the before validate, we can record the current balance of that account. Then after execution message, we will check again for the difference between after execution, and we will either revert or commit the transaction. So with that, we have a smart account that is compatible with existing Cosmos module. This is actually come from how smart contract is treated in Cosmos. It is just another type of account, and we keep that. The second point is that the smart account is managed by a key pair. I think this is pretty important because this is not controlled by another contract or another account. It is controlled directly from key pair. So for user, they can think that this is another account, another normal account, but with additional functionalities. However, with that, we still need a specific wallet design because, well, you know that, for example, Kepler, when you generate a new public key app, a new key pair, they will also generate for you the address. The address is predeterministic, so that well, now we want to change the address of the smart account because only so well, that's why we need a new wallet design that can work that allow us to change the address. Here is several applications that I can imagine, and we have, in fact, we are building as well. The first one is like we can choose a separated smart account for specialized purpose. For example, I have if I play a game, I can create a smart account for that game. Then I have the key. I mean the key that I use to create that account, and I can manage that account. However, the account is managed by the game, and with that, I can grant them many permissions so that they can work seamlessly without I need to sign every transaction. But by doing so, I still retain the control of the account with the key that I create that account. So it really helps a lot because they don't need to work with wallet anymore. They can store the key. I can let them do that. But it's easier and it's better for your users as well. Then the second one is account recovery. Well, this is kind of common now. For example, we have a Web3 out that let us using social account for recovery. Then, but with smart account recovery, we implement a entry in the smart account that let us change the corresponding top key, so that whenever we want to rotate our keys, we can submit a credential which will be validated in the smart account, and then if it's correct, we can change it to another public key. So with it, we can really rotate our key every week or so, and it is much better. Well, just like as the previous application, we make an app, we give it our key, but then after every session, we rotate it to another key. So we can be sure that it's, well, after I log out of that session, the application can no longer control my account anymore. And the last point is that, well, it is like combination of the previous point, that I can use one account to manage multiple smart accounts. Like every app, I use a different smart account. Then I use one, well, master account to control all of them and rotate key if I see fit. So, the next one I want to talk about is the indexer. So as a application developer, we know that we need to track the events of our contract in the blockchain. And however, this is very complicated processes. Here is a diagram showing how events in a Cosmos chain are emitted. We have a block one block has many transactions, then the transaction can have many messages, which also have many events, and we have to track all of those. It's even more complicated. For example, the transaction also have their own event, and the block also have event as well. Even more that, for example, our contract can be called from another contract, such as the previous smart account. Then, so we have to track also their event if we want to know what happened to our contract. So this is very complicated for the app developer to do so. Because of that, we make an indexer that tracks all of these events. And we have tracked all the events and assign it to the corresponding modules as well as the contract. For example, we have specialized tracking for bank, for staking, for government, and WASM. For WASM, we also extend more by assigning it to each contract as well. So we can easily query what event happening in what contract at any point. And then we put all of them in a GraphQL interface with and multiple chain in one interface actually. So we can build. This is not only helping the app developer but also helping aggregators and data analysis as well. As we support more application, we add more support for smart contract standards such as CW721 and CW20, where we not only tracking event but also integrated and well, you can say that we pass all of the event and group it into information. For example, we have own account balance and we checking the token data. For example, in the CW721, such as metadata. And we also combine them to standard activities for the related to the token. For example, transfer and such. Then we also support other standard contracts such as CW2, which give information about contract like their name and their version. We have planned for support more such as CW1155 or so. Then another issue is that the multiple contract versions. For example, when you upgrade to CW722 version, the event would change. So we also support for that. And well, that is for my talk. Thank you very much.